Welcome to the video reviewing exponent properties. We're going to be taking exponential expressions and simplifying them down to the cleanest form that we can set them in. This will include having no negative exponents and having numeric values reduced. There are 6 rules that we can use, or I guess 5. The zero exponent rule says any rule raised to the 0th power is 1. Any base raised to the 0th power is 1. The power property, when you have an exponent being raised to an exponent, you can multiply those two. For example, if I had x to the 3rd to the 4th, that would equal x to the 12th. If I have the product property, this would be a case of having common bases and you can add the exponents. So if I had x to the 3rd times x to the 4th, that would be x to the 7th. The quotient property allows you to divide. If there's common bases, you can subtract the exponents. So if I had x to the 3 divided by x to the 4, that would be equal to x to the 3 minus 4, or x to the negative 1. And then finally there's the negative exponent property, which says that if you have a negative exponent, you can move it over the dividing line and make that exponent positive. So if I have like x to the negative 3, I could write that as 1 over x to the 3rd. Similarly, if it starts out on the bottom, I can move it to the top by making the exponent positive. So if I had like 1 over x to the negative 4, I could move that to the top and make the exponent positive. Okay, we're going to apply these properties to these rules or these expressions to simplify them. The order that you apply them in does not matter as long as you apply each of them correctly. However, I will always go in this order for this video for the sake of consistency. So let's start with this. We have an expression, and the first rule we're going to apply is the zero exponent rule. So we're going to look for anything that has a zero exponent, and we're going to replace it with the number 1. Looks like we have y to the 0th. The y to the 0th was replaced with a 1, and we have our new expression. Now we're going to use the power property, which is applying an exponent to an exponent. So we are going to apply this 2 into both of those expressions. 2 squared becomes 4, and 2 times 2 is that 4. Now let's use the product property, and the product property is going to apply to the numerator. 4 plus 10 is 14. And now we'll use the quotient property, and we have the x to the 14th over x to the 17th, so we're going to subtract those exponents. 14 minus 17 is negative 3. Now we will use the negative exponent property, and that says that x to the negative 3 can be moved to the denominator to make it a positive exponent. And then finally we simplify or reduce anything else that we see further. And I see the 4/20ths can reduce. If we take a 4 out of both of those, we are left with our simplified expression. All right, that is example 1. The future examples will follow the same 6-step process. Example 2. We're going to apply the zero exponent property to that y to the 0th. That turns it into a 1. Now we're going to apply the power property. We're going to distribute that 2 in. 3 squared is 9, and x to the negative 12th squared is x to the negative 24. Now we'll use the product property. It looks like it applies in the numerator. Negative 24 plus 3 is negative 21. Quotient property, I see that we have an x in the numerator and the denominator, so we can subtract negative 21 minus 7 is negative 28. Then we'll apply the negative exponent property. We have negative exponents on both sides of the fraction bar. So the y to the negative 5 can move to the numerator. and the x to the negative 28 can move to the denominator, and then the exponents become positive. And then finally we do any last simplifying and reducing, and when I look at the numbers 9 and 16, 9 is 3 times 3, 16 is powers of 2. That doesn't reduce any further, so we don't need to take any further steps to arrive at our answer. All right, let's look at example 3. Zero exponent rule. I'm going to look for any zero exponents, and we have one right there, so that's going to be replaced with a 1. Replaced with a 1, 20 times 1 is still 20. Now we'll use the power property, and I have this negative 2 that can apply to all of these terms, and this positive 2 that can apply to these terms. Sometimes students have trouble with this negative exponent in numbers, and so rather than trying to figure out what 2 to the negative 2 is, I'm going to leave it as a negative exponent and apply the negative exponent rule in step 5 there, so that I don't make any mistakes there. Next up we have the product property, and I see a product of x to the 4th and x to the 10th. So when we add those together, 4 and 10 makes 14. Then I also see y to the negative 20th and y to the negative 8th. So negative 20 plus negative 8 is negative 28. Nothing to simplify on the bottom, and we still have that 2 to the negative 2. Okay, the quotient property, we have y's on top and bottom, so we're going to subtract those y's onto the numerator, so negative 28 minus negative 6 is negative 22. Negative 28 subtract negative 6 is negative 22. Finally, we apply the negative exponent property, which says I can move the 2 to the negative 2 to the bottom, and I can also move the y to the negative 22 to the bottom and make the exponent positive. And then we do any last bit of simplifying, and I can simplify those numbers. 2 squared is 4, 4 times 20 is 80. And when all is said and done, we should have all positive exponents and reduce to numbers, and we do. Let's look at example 4. Zero exponent rule applies to that a to the 0. Then we will apply the exponents 2 and negative 3 into each parenthesis set using the power property. The 2 as an exponent for 5 I turned into 25, whereas the negative 3, just to avoid any confusion, I left it as a negative exponent there. Don't forget that a negative times a negative makes a positive. Now we're going to use the product property, and we can combine our a's into a single term in the numerator and our b's into the single term in the numerator. Notice that b to the negative 12th and b to the positive 12th, those two numbers add up to 0. I did write b to the 0 here, but you'd be fine writing a 1 or even just leaving that spot empty, because multiplying by 1 doesn't change the numerator. Quotient property, we can take the b to the 0 minus b to the negative 6, and that gives us 6b's on top. If you had not put b to the 0 in here, then this step would have nothing to do, and we could move to the negative exponent step. And I just realized that I forgot my 2 to the negative 3. Okay. Next up is the negative exponent rule. I'm going to take the expressions with negative exponents and move them across the dividing line. So the 2 to the negative 3 moves to the bottom. The a to the negative 19 moves to the bottom. And then we're left with 25b to the 6th in the numerator. Simplifying and reducing, 25b to the 6th over 2 to the 3rd is 8 times 10 is 80. And then I see that 25 and 80 are both divisible by 5, so that can be reduced a little bit further. 80 divided by 5 is 16. There we go. So there's our final simple form. Example 5 looks pretty messy, but our very first rule is the zero exponent rule, and this 0 applies to that whole parenthesis set, so that whole parenthesis set is going to turn into a 1. Then we're going to apply the power property. We have a 2 to put into the denominator and a 4 to put into that parenthesis set in the numerator. 2 to the 4th is 16. 15 times 4 is 60, and negative 2 times 4 is negative 8. Now we'll use the product property. We'll be able to combine the a's to give us 63 a's in the numerator, and combine the b's to give us negative 1 b's in the numerator. Then we use the quotient property. I've got a's on top and bottom, so I can subtract 63 minus negative 4 is 67. And then the negative exponent property allows that b to the negative 1 to move to the denominator. B or b to the 1. And then 16 and 36 can be reduced. They're both divisible by 4, so 16 divided by 4 is 4, and 36 divided by 4 is 9. And it's always a good step to check at the very end, is there anything else I can do to reduce this? And in this case, there is not. So you can see that these steps will always get us to the end. Sometimes we might need to do a step more than once to reduce it a little bit further, or sometimes you might find that there's faster paths or opportunities to skip or combine these steps. So as you get more practice with them, you will start to learn how to see them quickly and do them a little more efficiently. But this 6-step process should always work for you. So I've got 2 more examples. Let's take a look. That x to the 0 disappeared because x to the 0 is equal to 1. Now we'll use the power property. Distribute the negative 4 into these 3 terms. And negative exponents I like to leave with numbers rather than try to simplify that expression. Negative 2 came in, 6 to the negative 2. Again, there's a negative exponent. Negative 2 times negative 2 is positive 4. 2 to the 10th, I went to my calculator, grabbed that number, 1024, and then y to the negative 40th. Product property. Oh, I just realized I wrote down an x where it should have been a y. Didn't follow my cardinal rule of checking every step after I finish it, but I recognized it now. Okay, product property, we've got 2 x's on top as well as 2 y's, so those will combine, and then nothing on bottom to combine. Still keeping my negative exponents with my numbers so as not to get too ahead of the self. 3 and negative 20 gives me negative 17 x's, and then 7 and negative 4 gives me 3 y's on top. Now we'll use the quotient property. Negative 17 minus 4 for the x's is negative 21. And 3 minus negative 10 is positive 13. And that's the quotient property. Then we'll apply the negative exponent property. 3 to the 4th moves to the bottom. X to the 21st moves to the bottom. Y to the 13th stays on top. And then when you look at the denominator, 6 to the negative 2 moves to the top. and the 1024 stays on bottom. Six squared is 36, and then 3 to the 4th times 1024, turning to my calculator again, is a very large number. And then if you have a TI calculator, you can reduce these fractions by typing in the expression. It gave me some number, and sometimes if you press the math button and convert to fraction, it will reduce it for you. So that reduces to 1 over 2,304. Certainly a more complicated number than I would give on a test, but there you have it. Okay, let's look at the last example. Start with the zero exponents. I see them, there's a couple of them. Then we'll apply the power rule, power property, the 2 and the -3. Then we're going to use the product property, combine these b's in the numerator. Then we'll use the quotient property with the b's on top and bottom. Then the negative exponent property. Bring that 3 to the -3rd to the denominator. And then we will simplify. And 225 over 162 doesn't reduce at all. The factors of 162 are 2 and 3, and the factors of 225 are 5. And so, oh wait, no, 5 and 3. They're both divisible by 3. 225 divided by 3 is 75, and 162 divided by 3 is 54. Ooh, can that go even further? It can go further. They're both divisible by 9. $225 divided by 9 is 25, and 162 divided by 9 is 18. There we go. And then just double check. 5 times 5, 2 times 3 times 3. Yeah, that's as low as it'll get. Again, your calculator, if you have the TIs, can do that much faster. We take 225 divided by 162, and then we press math, convert to fraction, and there we have it, 25/18. Okay, thanks for watching the video. Be sure to comment, like, subscribe, hit that bell for notifications.